Now, let us talk about Charles' law. As I said, if now we are discussing about these laws, they only pick 2 factors out of 3, and that 1 factor out of 2 is held constant. For instance, for Charles' law, we are just talking about the relationship between volume and pressure. Volume and temperature. Volume and temperature at constant pressure means the pressure is held constant of a fixed mass of gases. So here we are just talking about volume and absolute temperature. It is now, therefore, we are just looking the variation between volume and temperature at constant pressure. Now the pressure is held constant of a fixed mass of a gas. Means also the mass of the gas is fixed. Means we are just talking about the same mass at constant pressure. The same mass at constant pressure. Now this Charles' law means that the volume is in direct proportion to the temperature. The volume is that proportional to the absolute temperature. Now, removing the proportionality constant, that is to say, volume is equal now to KT. But this K is proportionality constant. It is what we call it pressure because that is what it is constant. Therefore, the V is equal now to KT. But remember, at different gases, at different conditions, at different conditions means there is a variation of volume and temperature because that is what we have said. But here what is constant is pressure because that is the one that is held constant at the fixed mass of the gases. It is therefore a different condition. Condition 1, volume is equal now to K T1 means the pressure is held constant and that is the proportionality constant. And therefore, if now the pressure is constant, if now the conditions, the volume is changed, now the temperature also is changed. V2 now is equal to KT2. If now this is the volume is changed, also temperature is changed because we have said volume is direct proportion to the temperature at constant pressure. That is to say K is proportionality constant and that is pressure because pressure is the one that is held constant under this law. Now this is the first equation and this is the second equation. Now by dividing these 2 equations, or by dividing is so difficult somehow because here K is equal now to V1 over T1 and here K is equal now to V2 over T2. Now these constants are equal. It is therefore now we say K is equal now to K means pressure at this condition is held constant and this pressure is the same. Means that the pressure at the first equation is equal to the pressure at the second equation. That is why V1 over T1 is equal now to V2 over T2. This is to say pressure is held constant. And other words, you would have taken V1 is equal now to K T1 and V2 is equal now to K T2. Now this is the first equation and this is the second equation. Now finding the ratio of these 2 equations, now this cancels out. It is therefore now we have V1 over T1 is equal now to V2 over T2. The same applied, this is V1 over V2 is equal now to T1 over T2. This is the same thing. Why is it so? Because from here now, you may have V1 over V2 is equal to T1 over T2. You may cross multiplication and find that V2 T1 is equal now to V1 T2. Now this can be used to determine the new pressure. So in short, as I've said that V is direct proportional to the temperature. Removing the proportionality constant, now we have V is equal now to KT. this is an equation. But proportionality constant is called pressure, because pressure here is what is keeping constant. Therefore, under different conditions, we have V1 is equal now to KT1 and V2 is equal now to KT2. Why is it so? Because there is a change. If there is a change in volume, there is a change in temperature also. If there is a change in volume, there is a change in temperature. Finding the ratio of these two equations, now you just have V1 over V2 is equal now to T1 over T2. This is an equation that can be used to determine the new temperature or the new volume that we obtain after you have changed the temperature. That is at constant. It is possible only at constant pressure. If now the pressure is really constant, this formula is possible to use it. Now let us see the example under this circumstance. Example, a 0.20 meter cubic container with an movable piston holding nitrogen gas at a temperature of 20 degrees Celsius. What will be the volume of the gas if the temperature is increased to 50 degrees Celsius? If you look at here, we have data. From the question, we've been given the volume 1, that was 0.2 meter cubic. And from the question, you've been asked the second volume that will be obtained. That is what? But at these volumes, the temperature that was there, the temperature 1 is equal now to 20 degrees Celsius. But what will be the volume at this temperature? 50 degrees Celsius. Now, at 0.2 meter cubic container with a movable piston hold nitrogen gas at a temperature of this one, what will be the volume of the gas if the temperature is increased to 50 degrees Celsius? When you look at here, we are just talking about volume and temperature. If now you find a question of this kind, what you have to do is to solve under the circumference of Charles' law. Now from Charles' law, V1 over V2 is equal now to T1 over T2. It is therefore, we have something here to note that V1 is given 0.2 meter cubic and T1 here is equal now to 20 degrees Celsius plus 273, because we need to convert it into Kelvin. Now we take 273 plus 20, we get 293 is equal now to V2, which is absent, over T2, which now it is 50. Now we take that 50 degrees Celsius plus 273. And the temperature here is 50. Now this is, now we have 3, then we have 2, we have 323. This is 323. This is now we are looking for the volume. Now the formula that I've applied here is V1 over T1 is equal now to V2 over T2 instead of this one. But this and this may be applicable. You may decide to use this one or to use this one. If now you decide to use this one, is okay. If now you decide to use this one, is okay. You get my point? Now it is now what, that is why you are looking for this one. Once you get this one, you close multiplication, you find it is 293 V2 is equal now to 0.2 times 323. Then we divide by 293, then we divide by 293. It is therefore you are looking for the volumes. It is therefore now you conclude the volume will be equal to 0.22 meter cubic after you have divided. This is a new volume. But all in all, the formula that can be used to determine the new volume is this one. But from the question, you look what is missing. What is missing here? What was missing here is V2. We have V1, we have T1, we have T2, but what is missing here? Then you choose whether to use this equation or this one, so as you may obtain what is missing. And that is why now we may apply Charles law. All in all, Charles law is applicable only if now you find there is a variation between temperature and volume at constant pressure. But if now you find there is temperature and the pressure, that is different law that you can be applied. And now once you find different ways, so we only consider the volume and temperature in Charles law. That is all about Charles law.